to the next point. We should ensure whatever we say is clear.
That means work is being done. We can see that it is in opposite direction.
My well-able learners, I'm Mr. Yakub Fidelix. Welcome you to another beautiful moment of our lesson in mathematics. We are continuing with the topic, solving simultaneous linear equations. And the subtopic is method of solving simultaneous linear equations, in which we are considering the first method known as the elimination method, which we have started earlier. Today, by the grace of God, we are going to see the example type 4. Example type 4. Find x and y if 3 to the power of 2x minus y equals 1 and 16 to the power of x over 4 equals to 8 to the power of 3x minus y. My dear learners, before we solve this, we must recall the two fundamental laws of solving simultaneous equations by elimination method, in which I have told you earlier. The first is make sure the equations are balanced. By balancing the equation, we simply means if we are using x and y as the two variables, then it means the coefficient of x in the equation 1 must be equals to the coefficient of x in the equation 2. It simply means that x is balanced. So also, to balance y, it simply means the coefficient of y in the equation 1 must be equals to the coefficient of y in the equations 2, which also means that y is balanced. Then rule number 2, if the coefficient of the balancing terms are the same, for instance, negative, negative, or positive, positive, then the rule says we are to subtract the equations. And if the coefficient of the balancing terms are not the same, that is, they are different, then the rule implies we are to add. For instance, minus plus or plus minus, we are to add the equations. So take note, please, of the two fundamental laws, because if you don't understand them properly, there is no how you can solve equations like this. Therefore, let's go further. Now, when you look at the two equations, they are written in exponential forms. They are written in exponential form. That means they are written using powers. So for you to solve them, you must translate them, or rather convert them, to linear forms before solving. For instance, like equation like the first one, which says 3 to the power of 2x minus y equals to 1. 3 to the power of 2x minus y equals to 1. On the left-hand side, there is a base 3. And on the right-hand side, there is no base. So you must find the means of introducing the base on the right-hand side. Now, 1 on the right-hand side can be written as 3 to the power of 0, because 3 is the base on the left. 1 can be written as 3 to the power of 0. Recall, one of the fundamental laws of indices is x to the power of 0, the answer is 1. X to the power of 0, the answer is 1. Or y to the power of 0, the answer is also 1. That is why the number 1 on the right, using the base 3, can be written as 3 to the power of 0. That is to say, by simplification, 3 to the power of 0 equals to 1. Now, the common base is 3. 3 on the left and 3 on the right is gone. And you'll be left with a what? With 2x minus y equals to 0. 3 on the left and 3 on the right is gone. So you'll be left with 2x minus y equals to 0, and I name it equation 1. Also consider the second equation. 16 to the power of x all over 4 equals 8 to the power of 3x minus y. It needs further simplification by applying the laws of indices. 16 to the power of x can be written as 2 to the power of 4x. Because 2 to the power of 4 means 2 times 2 times 2 times 2, and that will give you 16. So 16 to the power of x simply means 2 to the power of 4x. Divide by 4. 4 can be written in index form as 2 to the power of 2. As 2 to the power of 2, because 2 times 2 equals to 4. Then let's move to the right-hand side. The number 8 can be written in index form as 2 to the power of 3, because 2 times 2 times 2 will give us 8. So I now wrote 2 to the power of 3 into the what? The exponent, which is 3x minus y. And when you expand the exponent on the right-hand side, that is, you will have 3 times 3x will give you 9x. 3 times 3x will give you 9x. And 3 times minus y will give you minus 3y. 3 times minus y will give you minus 3y. So the right becomes 2 to the power of 9x minus 3y. Now, on the left, the base is 2. And on the right, the base is also 2. So you can see 2 and 2 is gone. You are now left with 4x minus 2 equals to 9x minus 3y. 4x minus 2 equals to 9x minus 3y. Now, by collecting the like terms, I will now have 9x. When plus 4 crosses to the right becomes minus 4x. When plus 4x crosses to the right becomes minus 4x. So I now have 9x minus 4x. And you are left with minus 3y on the right. The sign doesn't change there because it remains on the same position. That is on the right-hand side. So I now have minus 3y. You are now left with minus 2. You are now left with minus 2. Now, 9x minus 4x, the answer is 5x. Just like you have 9 oranges and you are asked to take away 4 oranges, you'll be left with 5 oranges. Then minus 3y equals minus 2. And I name it equation 2. Now, the next step is to bring the two equations together and solve them simultaneously by the elimination method. To bring the two equations together and solve them simultaneously by what? The elimination method. So the first equation, 2x minus y equals to 0, equation 1. And 5x minus 3y equals minus 2, equation 2. Now, when you look at the two equations, the x is not balanced and the y is also not balanced. The x is not balanced and the y is also not balanced. So if you are to balance y, then you are to multiply the coefficient of y in equation 2 by equation 1. If you are to balance y, then you are to multiply equation 1 by the coefficient of y in equation 2, which is minus 3. That's why you can see there equation 1 times minus 3. On the same way, if you are to, multiply the coefficient of y in equation 1 by equation 2. And the coefficient of y in equation 1 is minus 1. So you can now see me written equation 2 multiplied by minus 1. Now, when you do that, minus 3 multiplied by 2x, you will have minus 6x. Minus 3 multiplied by 2x, you will have minus 6x. And minus 3 multiplied by minus y, you are going to have plus 3y. Minus 3 multiplied by minus y, you will have plus 3y. And minus 3 multiplied by 0, you will have 0. Minus 3 multiplied by 0, you will have 0. If you also come to equation 2, minus 1 multiplied by 5x, you have minus 5x. Minus 1 multiplied by 5x, you have minus 5x. Minus 1 multiplied by minus 3y, you have plus 3y. Minus 1 multiplied by minus 3y, you have plus 3y. And minus 1 multiplied by minus 2, you'll have plus 2, as written below. So I have minus 6x plus 3y equals to 0. I name it equation 3. And minus 5x plus 3y equals to 2. I name it equation 4. Now, the next step I said, equation 3 minus equation 4. Why are we subtracting? Because when you look at the sign of the balancing term, which is y, the first equation, the coefficient of y is plus 3. And in the fourth equation, the coefficient of y is also plus 3. You can now see that the two signs are the same. And the rules of elimination method is saying where to subtract. That is why I chose to say equation 3 minus equation 4. You can also choose to put it this way, equation 4 minus equation 3. You still arrive at the same answer. So the first term, that is in equation 3 minus 6x, is written there. Then minus the equation, because of the same balancing sign, is also written there. Then then minus 5x in equation 4. I take that again. Minus 6x written. Then minus is the equation which came as the result of applying difference, because the two balancing terms are the same. So it's written there. Then minus 5x equals to the right hand side, which is 0 minus 2, equals to the right hand side, which is 0 minus 2. Now, on the left hand side, the two middle signs are negative, negative. The two middle signs are negative, negative. And by the idea of directed numbers, negative, negative give us what? Positive. So it now becomes minus 6x plus 5x. It now becomes minus 6x plus 5x. And by the idea of directed numbers, minus 6x plus 5x, you'll be left with minus x. Minus 6x plus 5x gives minus x. Also on the right hand side, 0 minus 2, the answer is minus 2. So I'm now left with minus x equals to minus 2. To find the value of x, I am to divide both sides by the coefficient of x. And the coefficient of x here is minus 1. So divide both sides by minus 1. So I now have minus x over minus 1 equals minus 2 also over minus 1. Minus 1 divided by minus 1 on the left, you'll be left is equals to 1. And 1 times x equals to x. Minus 1 divided by minus 1 on the left, you'll be left with 1. And 1 times x give us x. And minus 2 divided by minus 1 on the right give us 2. Minus 2 divided by minus 1 on the right give us 2. And therefore our x is equals to 2. Now, substitute the value of x in equation 1 for what? For y. Substitute the value of x in this equation for what? For y. And the equation is 2x minus y equals to 0. 2x minus y equals to 0. Don't forget, our x is calculated as 2. We got the value of x to be what? 2. So in place of x in this equation, we are going to write what? 2. So look at the first time there, I have 2x. And 2x means 2 times x. That is why I write 2 into 2, which means 2 times 2. Then minus y equals to 0. 2 times 2, the answer is 4. Minus y equals to 0. Collect the like terms by solving the simple linear equation. And of course, your y will become what? 4. Your y will become 4. Conclusively, our x is equals to 2 and our y is equals to 4. My dear students, don't forget, for you to succeed in solving simultaneous linear equations, then the two fundamental laws must be taken note of, in which I have given you before. One of the laws is make sure the equations are balanced. Let me explain that very well. Because we don't get the laws correctly, then automatically there is no way you can solve the simultaneous equation by elimination method correctly. What do we mean by making sure the equations are balanced? I simply means if you are using x and y as the two unknowns, then the coefficient of x in equation 1 must be equals to the same coefficient of x in equation 2. By doing that, it simply means x is balanced. So also, to balance y, the coefficient of y in equation 1 must be equals to the coefficient of y in equation 2. By doing that, it simply means that y is balanced. Then the rule number 2, I told you, if the signs of the balancing terms are the same, if the signs of the balancing terms are the same, for instance, plus plus or minus minus, you can see that both signs are the same. Then the rule is saying subtract the equations. The rule is saying subtract the equations. And if the signs of the balancing terms is the reverse, that means it's the opposite. That is, they are not the same. For instance, minus plus or plus minus, you can see that both signs are not the same. So the rule is saying we are to add the equations. We are to add the equations. Now, by solving this, these equations are written in exponential forms. These equations are written in exponential form. So for you to solve them successfully, then you must translate them or otherwise change them to linear forms before you now apply the elimination method of solving linear equations to work on them. For instance, like the first one, 3 to the power of 2x minus y equals to 1. You can now see that the left-hand side has the base, but the right-hand side does not have the base. So you must introduce the same base on the right-hand side. And that base is 3, you raise it to power 0. Why does 1 becomes 3 to power 0? Because we have been taught that one of the fundamental laws of indices is that x to power 0 will give you 1, or y to power 0 will give you 1. So certainly, by that, 3 to power 0, the answer is 1. Now, you can now see we have the base 3 on the left, and we also have the base 3 on the right, which means that 3 is the common base. So 3 on the left and 3 on the right is gone. And by doing that, you are left with 2x minus y equals to 0. 2x minus y equals to 0. And that gives you equation 1. So also, by considering the second equation, 16 to the power of x can be written in an index form as 2 to the power of 4x, because 16 simply means 2 times 2 times 2 into 4 places, and to give you 16. So 16x means 16 to the power of x means 2 to the power of 4x. Divide by 4. And 4 can be written in an index form as 2 to the power 2. Also come to the right-hand side. 8 can be written in an index form as 2 to the power of 3 into 3x minus y. So by expanding or removing the bracket, you now have 3 times 3x will give us 9x, and 3 times minus y will give us minus 3y. So I now have 2 to the power of 4x minus 2 on the left, and 2 to the power of 9x minus 3y on the right. The common base 2 is gone, and you are now left with 4x minus 2 equals to 9x minus 3y. By collecting the like terms, y plus 4x crosses to the right becomes minus 4x. That is why I have 9x minus 4x minus 3y equals to minus 2. So 9 oranges minus 4 oranges, or take away 4 oranges, you'll be left with 5 oranges. So I now have 5x minus 3y equals to minus 2, equation 2. Bring the two equations together and solve them simultaneously by an elimination method. I now have 2x minus y equals to 0, equation 1, and 5x minus 3y equals to minus 2, equation 2. You can now see that the two terms are not balanced, but I chose to balance y. By balancing y, I am multiplying equation 1 by minus 3, which is the coefficient of y in equation 2. And I multiply equation 2 by minus 1, which is the coefficient of y in equation 1. By doing that, I am going to have minus 3 times 2x will give me minus 6x. Minus 3 times minus y will give me minus 3y. Minus 3 times 0, I will have 0. And come to 2. Minus 1 times 5x, I will have minus 5x. Minus 1 times minus 3y, I will have plus 3y. And minus 1 times minus 2, I will have plus 2, as written below. So I now have minus 6x plus 3y equals to 0, equation 3, and minus 5x plus 3y equals to 2, equation 4. You can now see that the sign of the balancing term, which is y, are the same. So we have to subtract the equations. So equation 3 minus equation 4. You can also see equation 4 minus 3. You are also arriving at the same answer. So minus 6x, the first term on the left, then minus the equation, which is as a result of subtraction, is there. Then minus 5x in the equation 4 is now equals to 0 in equation 3 minus 2 in equation 4. We can now see that on the left there are the two middle signs are negative and negative. And negative equals to positive. So I now have minus 6x plus 5x. And by idea of directed numbers, minus 6x plus 5x will have minus x. And 0 minus 2 will give you minus 2. So to find x, divide both sides by minus 1, the coefficient of x. So I now have minus x divided by minus 1, and minus 2 divided by minus 1, and our x will become 2. Substitute the value of x in this equation to obtain the value of y. So don't forget, wherever you see your x, you replace it by 2. So that becomes 2 times 2 minus y equals to 0. And 2 times 2, of course, the answer is 4. Minus y, you have 0. So by simplification or by solving, your y becomes 4. Conclusively, our x equals 2 and our y equals to 4. My dear student, before we close for the day, I have an assignment for you. Assignment: solve the following pairs of simultaneous equations. 1. 2 to the power of x plus 2 to the power of y. I take that again. 2 to the power of x plus 2y equals to 1. 2 to the power of x plus 2y equals to 1. And 3 to the power of 2x plus y equals to 27. 3 to the power of 2x plus y equals to 27. Number 2, 27 to the power of x. 27 to the power of x. Divide by 81 to the power of x plus 2y. 81 to the power of x plus 2y equals to 9. And x plus 4y equals to 0. I take that again. 2 to the power of x plus 2y equals to 1. And 3 to the power of 2x plus y equals to 27. 2. 27 to the power of x divided by 81 to the power of x plus 2y equals to 9. And x plus 4y equals to 0. References on my research are as follows. New Journal Mathematics by M.F. Makre, Z.I. Chima, G.U. Garba, and Ita. Then 2. Mathematics Clinic by Bakare L. May. And we have Mathematics Question and Answer YA. My dear student, particularly SS3 that are still preparing to write their NACO, and SS2 students, this topic is for you. Make sure you rehearse on this topic, practice very well, and I'm assuring you, you will have better understanding. I remain your teacher, Mr. Yakubu Fidelix. You can get me through this contact as usual, 080-2525-5287. Yakubu Fidelix, 080-2525-5287. Stay safe, keep learning well. Thank you.